Greetings everyone and welcome back. I accidentally made a boo-boo and forgot to record the audio on this video. So I will be just doing a voiceover over all the stuff that I cover in this video. And so you'll have to excuse me if some of the stuff I say doesn't catch up with stuff, but instead of re-recording this video, I wanted to kind of just make sure you saw all the steps, the process I went through, and I can just give a little bit of commentary onto what exactly I was able to do. So the topic that we'll be discussing this time is changing the behavior of a section of code. So this is in the series of refactoring. So we just covered kind of shielding all of our changes that we were about to make with unit test. And so now we're about to just kind of deep dive into how might we change just, in the first example of kind of refactoring some code is just changing the behavior of a function or class. And so changing behavior can come in a lot of different variations. You can kind of change something inside the function. You can change individual lines of code. You could completely gut the function and make it completely something different. You could change the class to be a completely different type of class. So this is just kind of walking through that. So one of the things that I'm doing right now is I'm kind of clicking through showing you that this is the project layout of all of our tutorials. So you can kind of see that, up in the top, I have a refactoring project that has my main code. And then at the bottom, I have a refactoring test project, which has this code that you're seeing, this unit test class. And with this unit test class, each time we do a video, I'll just copy the the code from the video before, and we'll just continue to iterate off of that code from that video. So this is just a copy of the code that we made when we were doing the shielding changes tutorial. So here I am, I'm just going through changing all the code to route to changing behavior. And so you can kind of see that this is what this code is doing is referencing the changing behavior names.txt. And so we don't want it to reference the making shielding changes txt, because then we make changes to our names.txt that won't be updated in the unit test. So just kind of making sure all my code is routed correctly, my namespaces are set up correctly, my classes are all referencing things as they should be, just to make sure that this is like a nice standalone project that we can kind of iterate on and just continue through with this new tutorial. So right now, I don't know what I'm deciding right now, but we're looking at this code that we wrote last time that was reading all the lines out of a file, and then we were going to inject those into a list. And so one of the immediate things there is this ghost code that was a bit more optimal than the code that we ended up using at the end. So we might make some decisions on whether or not we want to go towards that. So yeah, it's clear I'm doing some kind of discussion on the different types of, and maybe I'm discussing the different types of refactoring. So like I say, this one we're kind of going into is this changing behavior refactoring, and then there's multiple different types, and you can see them all listed out on the left panel. We can increase readability, we can make something faster, move something somewhere else, and removing code. Before you do any of that work, you should always shield your changes with unit tests, because you want your unit tests, which are over there on the right in the green, we want them to always be green whenever we make any changes to our code. And so when you're, you can think about making a unit test, making sure that unit test is all green. Then we make a change, we save the file, we run the unit test again, and we check it. We check our unit test and make sure that they're going all green before we move on to the next subject. And so that's just a good habit to kind of keep in place when you are refactoring a piece of code. So this code is all very simple, but you can imagine that a project might be complex and you're doing all these different types of refactoring all at once. So you want to just make sure you have some solid foundations in place. So one thing, and I can't quite remember if we're going to do that here, but we are parsing events out, but you could easily think about the opposite scenario, which is maybe exporting these events out to a file. So that functionality would be pretty nice to have in this class called Events Parser. So we might just be discussing what's the thought process we could have with implementing that out. And there's different design ethos around that. Some people don't believe that you should make any code that you're not going to immediately use, and so this is just an example that we just imagine that you were building some kind of parse events function that was reading a txt file, and you needed to be able to read it, and you also need to be able to export to it. So it does look like we are going down the route of just adding on an additional endpoint. Some people might call this an API endpoint. And so you'll kind of hear a lot of verbiage, but here we are just kind of expanding the functionality of our events parser class and giving it the ability to now export these events. So with parse events, we had to assume that we were given some txt file, and that txt file needed to kind of be formatted in a certain way. And right now we're generating that all by hand. And so that's kind of culpable to human error. It's very hard to kind of know what's going to be output, what kind of input we're going to get. So it can be really nice to make functions like this that people use, because when you have a function like this, you can define it exactly how you expect it to go in. You can define all the formatting here. And so now you've built this kind of quote unquote architecture for your txt file inside of a function, and you just tell people use this function when you want to write a txt file. Don't just write it by hand, even though it might look simple to you. I have all these weird encodings, I have all these shorthands that I might encode with dump events that someone else might not think to type out just with their by hand. So in those cases, it can be really good to just have a function that you can use to just dump everything into it. So with this function, we're kind of thinking about what are the parameters that we might feed into a function like this. So this is a little bit of design. You don't want to give too many things, but you can think of a lot of things, right? So with dumping something into a file, we might want to give the user the ability to specify the file name of that file, of that txt file. So in this case, we are exposing the parameter file name to some unspecified caller. And then we're also going to give them a list of names that we'd like them to write. And notice how this is not a list of strings. And I believe we'll have that discussion a little bit later. But yeah, notice how this if we could choose to just give someone a list of strings and just let them kind of give it to us in any format, but we're specifically choosing name. And there's going to be a few scenarios that we walk through because of name. And name has to end up being a design decision that we made to lock into this exact class or this exact struct. So in case people haven't seen this before too, I'm writing a comment on this piece of code. A comment is just a great way of letting someone know, but without reading your code, just what all is going on inside of it. Inside of Visual Studio, to make this nice looking comment section, you just click the / 3 times. And so on line 53, I just clicked it 3 times, and that's what gave me this like nice little layout that had all my parameter names in it. So just FYI. So we've built out the shell of dump events. We could have given a lot more parameters to that. We could have been like, what kind of file extension do you want to use, and is this deleted on machine shutdown and stuff. So you can really think how a function like this can actually get really complex. And so we're intentionally only coding for a very specific use case. And we can always come back later and add that stuff if it's really urgent. But we don't want to overly complicate the class. So here we're using kind of, and actually we're having a little bit of a struggle figuring out what the API is that we might need to use to write this text file. So you can always try to do something like this of, try to figure it out from the IDE, but always what's going to be the best bet is just to go to the internet, look up an example of someone writing out to something. So it is good for you to see kind of the struggling that I'm doing here and just how I might figure out this, right? Because one of the issues here is this file open-write opens up a stream object, but it doesn't really open up a writer, and it's hard to figure out how to turn that writer to get a writer from a stream. So and yeah, if I were, for 19, I don't use the code on line 19, which is that file to open text. I don't use that code very often, so I would have thought the paradigm would have been just the same for writing, is that I need to, open text to read from it, and then I need to open text to write to it as well. But the fact of the matter is that I did not actually have to open any kind of stream to write to it. I probably can, but there's a much easier way to use it. Here you can see some great examples of just some APIs that are much easier to use, that I can just send in a full string, or I can keep calling it and sending in each line of the string to this file. So just doing some quick reading up of an example here. And this is an important skill to learn. You can sometimes see these docs, and I'll make a video on just how you can read docs and not get intimidated by it, but it can be really intimidating to see all these selections on the side left and be like, I don't know, do I have to read all these things to know exactly what to do? No, you don't. All you need to do is learn to parse for exactly what you're looking for. And you can always come back later. I like to keep my files open so that maybe later in the day I come back and just read over it if I have some time. But usually I don't really have the time, and so I just have to kind of move on, and I'll come back to that article later. And next time I come back to that article, maybe I'll read around it to learn a little bit more. So here's an example. So that write all text async function that we found on the internet, it takes in the string name of the file that we want to write. So it takes in the parameter pretty easily. And then it also takes a string for what you want to dump into that file. So the problem we have is that we have a list of names. And while they, human wise, it's very easy to think about how I would convert a list of names into strings. This function obviously doesn't have a concept of a list of names. And that's not going to get converted automatically for me into a list of names, or just a string form that's nicely formatted with commas or new lines, how I might want it. So here we're going through a couple of options that we have now, because the problem is I have to convert this list of names into a list of strings. So, or really just one giant string. So here's an example of one way to go about it is you define a toString method on this class. And so at the beginning, and we'll show that at the beginning, when the toString method is already defined. It's defined on all objects inside of C#, and it reads out just like this object name, and also that in the future. But what we just did now is we overrode the toString method. Now, silly me, I think I forgot that this was a list of names and not just an individual name. So I can't just define the toString method on a struct and expect the list to turn the list of structs to turn into a string like very nicely for me. Or I thought the API took a list of something and wrote it out, because I did see like an array example, but that's not how I really want to call this method at the end of the day. So what I'm going to do is I'm going to end up turning this list of names into maybe first a list of strings. And then once I have that list of strings, I can quickly append all of those into a single string. I can cut out the converting into a list of strings and just go straight into a string buffer array that I keep appending to. All of these things kind of have design trade-offs. So one might be easier to read, but one might take up less space. So you kind of have to figure out some of those trade-offs and some of those skills you just discover over time. And there's not always going to be an optimal answer. Sometimes the best answer is the one that you have coded, right, and that you fully understand, and that it's easy for someone else to come after you and fully understand. So in this example, I'm going to just use the buffer method, and I'm just going to keep appending to that string, and I'm just going to walk through each of the names that I already have, and I'm just going to walk through that and just append those names to file name, to name as string. And note here, we'll come back to this, but there's actually a bug in this code, so I'll leave that to you to find, but you'll see why it's important to have unit tests. So here, that code is really simple. Now we converted all the list of names into just a single string that had the list of names all separated by a new line, and now we're going to dump that into a txt file. So if you run this code, everything is going to look perfect now. And now we can build a unit test around it just to test it, right? Just to make sure everything, and this is one of the easiest ways. I think unit tests are way easier to test your code or see the output of your code than just going to the terminal and trying to run your code. So I think here I was trying to figure out how to make the little cute comment sections, but that's for another time to figure out. But yeah, here we're just going to make a unit test to test dumping to a file, and let's just make sure everything works, everything looks good. Like I say, you can make a program to run this and set up everything for you, but I think a unit test is a lot nicer to use. You get your interface over here on the right. You just save this file, all your stuff's going to pop up on the right, or maybe sometimes you have to build the project, but this is super easy to use. You can see you can reuse a lot of code from other projects. You're not having to rename things every time. When you're programming in the main function, sometimes you have to keep renaming stuff, and it's like that can just be a pain. So this is a nice, easy way to just code out. So here we are. We have just an example list of names. We actually just stole those from the exact match test above. And we're just going to call our dump events method and dump those names into it. We have to give it the name of the file that we plan to dump first. And that file is going to get dumped to your bin folder. So wherever the test gets compiled to, you're going to find this file there. So if you're looking through your file explorer, just know that you need to go to actually where everything got built. You're not going to find it next to this project code. So on the left, you'll never find that code there. You need to actually go into File Explorer, go into Finder, and try to find just the name of this file. So you can definitely use the indexer on Mac. The indexer is very good. Just type in test create dump, and you'll be able to find it. And then so here's a great example too. So here I'm saying, hey, I could actually specify whatever file extension I want. And this can actually end up being a bug, a very bad bug in your program. So someone malicious might come in and say, I want to specify .ps1 as the extension on this txt file. You might say, well, I mean, it doesn't matter. It's not like it's ever going to get processed or called. Well, you don't know how someone might use your code later. So someone might just grab your function and say, oh, well, yeah, I actually do plan on creating a function, and I am going to run, it's going to just be a function of script lines, and I'm just going to run every kind of script in that line, right? So it's like it'll be, the first line is like test.sh and test.bat and test.ps1. Well, then someone malicious might come in, and if they can somehow get a text file set into the right location, then your code's going to execute that text file and it's going to be parsed correctly. So you want to you sometimes you want your code to be super extensible and easy to use and expand and stay around in exactly the same state. That can be kind of addicting to try to go after, but sometimes it's better to just make your code very simple, code it for the simplest use case, and then just expand on it later as you need to. So in case you're wondering, some of the stuff I'm doing here, I'm just fixing more namespace issues inside this code. So some things I didn't rename some things like I should have, and so I'm using the compiler to fix everything for me and just tell me where everything is failing. So it's one way of going about this. I could have been a little more decisive with it, but yeah, this is one way. So here we see that we did successfully dump everything out, but this doesn't really complete the loop for us. So we want to make sure that we dump everything, and then that everything that we dumped is what we expected in the first place. So so here we are. We actually just went to the computer and we just saw, okay, things do look like how they should look, and so we do look good to go here. But you'll notice that there is still a bug here, and I'm curious if anybody is aware of what the bug might be. But there is a bug there, but everything looked good to the human eye. So we might be like, let's ship this, right? But this unit test is not complete. So we can improve this unit test, and you might already know we can improve the unit test by reading the file that we just created and read that again. So you can think about the code that we have above. All we're going to do is just pretty much copy and paste that code from above and just read that back and make sure that everything just read through it and make sure everything is as we expected. Now, making a unit test can be kind of complicated, and I can understand, maybe not understand, well, why is that the perfect test case? Well, what we're doing is we're testing every single endpoint that we created, and we're testing kind of all the cases for that would come into the endpoints. So we have two endpoints. If you just test one, you can only be sure that you can't really be sure that one did what you expected it to do. So you kind of need to know, you need to be able to judge the full output from any code that you do. So just because code executed, and so like in our case, parser, when we do this parser.dump events call, it executes a write of the file to the system. And so we don't, file execution or file creation, that's the only thing that we're testing in this unit test right now. We haven't even tested if the format was right, but by coming in later and saying, well, I'm going to read that file and make sure that it was tested properly, that's how we complete the loop for unit test and make sure that we have something that is actually usable and is actually testing exactly what we want it to test. So before, the way we coded it up to line 84, all we were testing was the writing of this file. And so we're pretty sure that writing files to the system is always going to be easy. We're pretty sure converting a list of names into a string is always going to be easy. But what we really wanted to test was that file output in the right format. So just always stay aware of exactly what you're trying to test for and make sure your unit test matches what you're testing for. And as you write more unit tests, you'll start to see, oh, I didn't write a unit test to test what I thought I did. I wrote a unit test that tested the function. And it's like, that's not what a unit test is. It tests for a certain behavior, right? So, and you'll try to name your stuff accordingly. So what we ended up doing was actually we happened to build a full round test, but you don't always have to kind of complete the loop in this way. So here we are, we're just expanding, adding another name, and just showing how easy it is now to expand this unit test, add on more use cases. Before we would have had to make a names.txt file and then add this explicitly to that names.txt. And maybe we would have had to, if we were making another test that had 4 names instead of 3, we would have had to make a new names.txt, like maybe names2.txt file just for that unit test. Now we don't have to do that. We can always just write, as many names to a file as we want, and just give it a unique name for a certain unit test. And you don't even have to do that. As long as you clean up after each unit test, you can let them all have the same file name. So here we're just kind of looking back, making sure, have we tested all the endpoints correctly? Are we looping? So, here we have loops. And so we just want to make sure, is our unit test going through each loop and just testing all the use cases that our function might come under. One thing that we won't code up is just a unit test that tests if an empty list of names comes in. That sometimes can be a useful unit test to make, but I would say when you're using for each loops, that's kind of always covered. But sometimes you do want to cover null cases and make sure things are handled appropriately. Usually the problem will kind of dictate whether or not that's a good idea. So I'm not sure what I'm explaining right now. Or maybe I'm explaining some of the things I was just talking about. Oh, did we run it? Okay, so I think we ran it and it came back with a check mark, and that was a bit unexpected. So what we want to, that's actually unexpected. You might say like, what? So this actually means that we didn't make a strong enough, or actually I think this is a bug in the Visual Studio, because I think if we ran it again, or if we do a clean build, it would actually go green. But yeah, here we're explaining just we do want to tie down the txt indicator on all of our code. So here we're just going to add this piece of code and then just show you how this might break. So just one little change that you made. I only accept txt files. I don't allow the parsing of events from a PS1 script or anything like that. So this change to only parse from txt files might change it. And when I say only parse from txt, the reason it's only going to parse from txt is because we append .txt to the end of the reader. And so that means that the reader is going to only look up txt files. So we can see that on the right, we got a lot of failures. And so if you went through and read each failure, you might just kind of see, couldn't find this file. But we see that none of the tests fail on our old unit test project. And so that's really important. That's the most important thing about unit testing and refactoring, is that refactoring should only affect the areas that you expect. And it's always good to make sure that you are run the unit test from your parent. So if you're working inside of a class, try to run the entire project's unit test, not just that single class's unit test. I know that sometimes that can be expensive and it just takes a long time, is what expensive means. But yeah, try to still run the code around you, because that just lets you know that you're not doing anything too wild, and you're making the changes where you expect to make them. Because in a way, this is surgery, and you're doing surgery. You just want to make sure that you're not operating in an area that you don't expect to be touching, right? And that you're going in affecting the lungs, but you don't expect the heart to stop beating, right? So it's just good to make sure everything is working as you would expect. Sometimes, and so yeah, here we go. We're going through fixing our unit tests, and this is a normal maintenance moding of a change like this. So we're changing the behavior of our class to only accept txt files now for the parsing. And it might have been nice to kind of show an example of, this was how it could have accepted .bat in the future. Here, so this is exactly what I'm talking about. Sometimes you need to do a clean build of your project. before it really picks up the new code that you're writing out. And I mean, in this case, it looks like I just did a build. See, I need to try a clean build. And see here it's saying still file not found. And so you know that you didn't code, this code should not be putting out this kind of an output. So that can kind of give you a hint that, oh, something didn't build correctly here. So here I'm double checking my code, just making sure, yeah, I am properly appending that .txt. You know, I have my names.txt file on the left, and it's named correctly. So seeing an error like this, it can be tempting to go over to your left and change the names.txt to names.txt.txt. That is not the solution to the problem. When you have a sneaking suspicion that something's going wrong when it should be going right, always check the compiler, always check the IDE, make sure that it's doing what you expect. And sometimes a clean build does exactly what you expect. So so we have this error all of a sudden, and it said expected 4 but got back 5 on this piece of code. So this is in the code create and dump file test. And so you see we're sending in 4 names, but for some reason 5 names are coming back. And so this is relevant. So this error would show up earlier. If we had built correctly, it would have shown up at the very beginning. But now we're seeing this error, and so we're kind of looking at our unit test, and this is kind of the first step. Is I start to blame my unit test. Is it coded correctly? But you know, this was code that I copied from the previous unit test, so I'm pretty certain that that code is correct. So now I might go, now I'm trying to go look at the actual file that came out. And so when I look at this, and boom, I see a new line at the end of that file. And that's just a sneaking suspicion that I have thanks to all my years of coding. But I knew that I had coded in adding a new line on the for each loop at the end of each name that I find. And so I had a sneaking suspicion that I had an off by 1 error, and lo and behold, I did. So that's what we're about to go solve right now. But you'll start to kind of get these Jedi mind tinglings as you get further along in code. But this is just a clear example of kind of an off by 1 error. What I should have done was I should have been a little bit more careful and specified that I wanted a new line on every line except for the last line, because my parser is going to come back later, and it's just every line that it finds, it's going to read that into a name variable. And new line is a valid character, so it will get read into a name variable as that character. So I don't filter out new lines in my parser code. So there's 2 solutions to this, right? You could have changed your parser code to ignore new line characters, and so that complicates it a little bit more. But in this case, this is totally a bug on my dump events function. I want to make sure that my dump events only dumps the exact number of names that I have, and that's what most people are going to expect. So when a human comes along and reads this code, they're not going to expect and dump events is a really bad name, and we'll change that name in the future, but they're not going to expect when I send in a list of 4 names, I'm going to get out 5. And you know, it can be tempting to just leave it and go and say, well, this works most of the time. Don't do that. In this case, really try to solve the problem and fix it and code it well so that it's easily extensible, and make sure that the fix to the problem is very easy and simple to understand and easy to build on. So in our case, we are just making sure that a new line only gets added on all the names except for the last one. So we can kind of code an easy if statement. We might not be able to use our for each loop anymore. For people used to Python, you can kind of add the enumerate on the loop, and then on the last index you could have kind of said, okay, don't add the new line. But in our case we can't do that here. here is an interesting example. So what I'm doing is I'm looking for, I was looking for a to join on commas method. And so I believe that that might be a part of the link library, or sometimes people will code those kind of helper libraries up for you. And what join on comma or join on new line might just mean is it takes in a list of some arbitrary type that can resolve to a string, and then it joins all of those strings with some character. So a new line is a character, a comma is a character. So you can, sometimes people will make those generic join lines with this character, and we might actually code that up ourselves, I think, in a later video. But yeah, we don't have that method here, so we have to code this up. And so here what we're doing is we switched from using a for each loop to using just a normal for loop that uses an iterator that we define ourselves. That iterator is I. We set it equal to 0, and we're going to iterate up to the count of names to dump. For people that are new to using list, make sure you always use the dot count and not the dot capacity, because capacity expands faster than count sometimes. So you will get an index out of bounds. So here we go. Code looks really similar right now. And now we're just, so you can see how I simplified the logic here. Instead of trying to do this if statement with like a ternary, like on the first line, it's like, it looks really cool, but for people that don't know what it is, it doesn't matter. But it might look really cool to have like all these if blocks all on one line, just making this code one line, but it can be really hard to read. But here I just say add this name onto this name as string, and then later let's figure out if this needs a new line on it. And we know that on the last, when the iteration equals, yes, exactly, count minus 1, that which is the last element in our list, when it equals that, then it will not get a new line. So, okay, exactly. So, yeah, if I kept it as equals, that would have been a bug. It only would have added a new line on the last element, but now it's going to add a new line on every element but the last element. Multiple ways that you can code that kind of logic up. Feel free to think of some clever ways yourself. So here we are, we're testing it. And see, this is a great example. This is why it's great to have unit tests. I was in a hurry. I ran my code quickly, and I had left the code from the previous run. So it was adding the names double time. So excellent reason to run your code through your unit test constantly and just make sure your unit tests are passing. So everything is all green. We have now switched over to this new method that's only adding a new line at the end. We got a green check mark on that exact match test, and that's looking great. So now we've changed the behavior of this class. We've added a whole new function inside of it. We've also changed the behavior of the previous function because it has the .txt restriction now. So this is just two examples, changing the behavior of a class by adding a function, and changing the behavior of a class by actually changing an old function that used to already be there. So very good examples. And these are examples of things that you will do constantly. So it was great that we ran into all the trouble that we did, because it shows you just how tricky refactoring can be, even for someone that, I wrote all this code myself, and going through it in a very processed way reveals a lot of the flaws that might come up when you're moving through this really quickly. Whereas if you had said, I'm going to build the dump events function, and while I was building the dump events function, I realized that I need a text a restriction, and I'm going to go add that. I'm going to add that line of code to my parse events function, and I'm just going to write up all my unit tests later. What would have happened is that you would have run your test, and you would have gotten all x's, and you would have had to go through each individual unit test and figure out, why is that x going? I need to change these names. I need to remove the .txt. Why is it still xing out? It's because I have a new line on my dump events function. Why is it still xing out? it's, oh, I didn't change this file name to be exactly what I want. So it can be so important to have a processed approach. When you make a change, run your unit test pass, just make sure everything runs as you expect. And if you made a new function, make sure you go ahead and write a unit test for that function as fast as possible. And it doesn't have to be very complex, but just test the basic functions and then keep moving along like that. That's how you make sure that your code has the fewest number of bugs in it. You can try to write your unit test at the very end, but I promise you're going to let a bug slip through. And then also on top of all this, make sure that if you're coding all this and stuff inside of a repo, make sure that your repo is building your code and running your unit test in there, because that gets around the compiler issues that we were having before, where things were compiling just fine and running just fine locally, but then we had the issue where our unit tests weren't failing locally. And so you could have imagined we would have checked in all this code, we would have seen green check marks on the right, and then we would have moved the code up and just sent it up to master or main branch. Whereas, we might not have thought that, oh, I wasn't doing a clean build of my project. You might just forget, especially if you built it properly, right? You did everything right. You built your projects and you ran the unit test and it showed all green. You feel like you did everything right, but then because you built it in the cloud on a different machine that was set up exactly how your project might be expected to set up, because you have this other cloud running your project and building it like you want, it sets up another environment to make sure that you don't face the issue that so many people face of, well, it ran on my machine, but it's not running on your machine. So that's a great way to just have your cloud build or whatever set up so that your repo is building your project every time you submit a code change to it, and make sure that it's running your unit test that you have in that project and that everything is looking good before you try to check that code into your master or main branch, because that could have been a pretty brutal bug to have let go out to main, and it might not be a very easy fix to change that code, right? We can't necessarily assume that this is a service. And so I might code that issue into an operating system, and it might take another month, 2 months before I can put out a patch for that operating system. So, and that was a very innocent bug, right? Oh, I didn't have it. This thing is supposed to have .txt, or oh, this thing was supposed to have a new line. It was a very innocent bug, but it could break all your production clusters, because this might have been a very core method. Like all you're doing is parsing a txt file. So you could imagine a database might be written completely in that way, of that it's just parsing a txt file for events and then dumping all of that stuff into some other piece of, like a list for a bunch of other pieces of code to use. And so you went and added this code because you were, I'm optimizing here, and you added this piece of code that ends up breaking kind of a core piece of code, just because we didn't do a clean build locally, and we weren't constantly building our master or main branch and running our unit test pass against it. So just, that was a long-winded explanation on why you should have test passes in your repo before you check in your code. So that is it for doing the changing behavior of refactoring. So the next thing I have set up for us is we will be doing increasing the readability of our code. And so that's just going to be continuing us on our refactoring series. I believe that I might not have recorded my voice on that one as well. So I will be back for commentary on that, but then we should be good with just normal dictation in the future. So thanks a lot for tuning in on this, and I hope to see you back for the next video.